Hey guys, we're going to be talking today about lesson 2-7, percent of a number. So the last two big parts of this chapter deal with multiplying with the idea of a percent, okay? Today's date is 12/11/19. So here's what it all boils down to. Let's say you're given a problem like this. 57% of 12. So you're going to start seeing some words. So the main thing that you have to do is realize you can't multiply by a percent or do math, let's say do math with a percent. Okay, so what you're going to have to do is figure out what you're going to change it to. So you have two options. Change percent to a fraction, or you can change percent to a decimal. Okay, and that's what we're going to be talking about in our examples, okay? The other thing, and I kind of gave it away, as I always seem to do, is this word of. It actually means to multiply, okay? So when you're being asked to find a percent of a number, you're going to be using multiplication. So we're going to use multiplication to calculate the answer. Okay, so let's see. Let's just go back here and reiterate that when you change a percent to a fraction, you're going to take that percent number and you're going to put it over 100. And if you're going to change it to a decimal, we're going to divide by 100. Move the decimal point left 2 places. Okay. Basically what we're going to talk about, I'm going to see if I can squish it in here. Let's see. Hold on a second. Okay. I put my little foldable off to the right side, and we'll deal with it in a second. But before we do that, we're going to talk about there's 2 strategies that we can use with the percent. And we talked about changing it to a fraction or changing it to a decimal. So what we do want to review, though, are some things about multiplying with fractions and things multiplying with decimals. So let's start with the fractions. Multiplying fractions. Okay, so this is something we talked about at the very beginning, is we're going to try to cancel out common factors. Common factors of any numerator with any denominator. Okay, so that's always something I like to do first. I called it pre-reducing. So how does the math actually work? Well, you're going to multiply straight across. And that means numerator, and I'm going to abbreviate it num times numerator. Hello, if I could spell. Numerator over denom times denom, so short for denominator. Okay, and then simplify if possible. So if you didn't reduce first, and even if you did, you still need to check to see if you forgot something. So always simplify if possible. Okay, so those are some things to keep in mind if you're going to try this method 1, where you're going to write the percent as a fraction. Okay, let's talk about the other guy. We're going to multiplying decimal. So that's going to be our second strategy. So some things to remember with multiplying with decimals. First, you're going to ignore the decimals. And multiply the numbers. Okay, and after you do that, we need to place the, oops, I got a little blotch over here. You need to replace that decimal back into the answer. So to do that, we're going to count the number of digits after the decimal points of each original number. Okay? Then we got to put the decimal into our product. So the product slash answer, oops, try to think two things at one time, answer will have the same number of digits after the decimal. So this is just reviewing back to chapters 3 and 4, okay? All right, so let's look at the situation we got here. We got a circle graph with, looks like 300 students are at this York Middle School, and we need to find the number of students that have cheese as a snack. All right, so we have to look through this, and we need to find where it talks about cheese. And I see it right here, and it says cheese is 15%. So I'm going to write that here. Cheese is 15%. So 15% of the students at this middle school have cheese as a snack. Okay? I'm going to go ahead and erase this guy right here. Give myself maximum room. Okay? So basically what this problem is asking us to solve is 15% of the students, which was a total of 300. Okay, so if I'm going to write this problem as a fraction, what I'm going to do is take that 15%, drop off the percent symbol, and write it vertically, divide by 100. As we said before, of means to multiply, and 300 is the other number. Now, I can only multiply when I have fractions, so I'm going to create a fraction out of my whole number by giving it a denominator of 1. So now what I'm going to look for is anything I can cancel out. And I notice that there's 100 in the denominator and a 300 in the numerator. So 100 goes into itself once and into 300 3 times. Now I'm going to go ahead and multiply straight across. So I'm going to just do this step by step so you can see it, just as a reminder. So we would have numerator times numerator over denominator times denominator. So 15 times 3 is 45. 1 times 1 is 1. And 45 divided by 1 is 45. So I would say 45 students have cheese as a snack. Okay, and that would be my final answer. Now, let's solve that same exact problem. How many students are going to have cheese as a snack? We already know what the answer is, right? But this time, let's do it as a decimal, okay? So we're going to take that 15%, oh, I'm having trouble writing here, there we go, and we're going to turn it into a decimal. And remember, we just divide by 100. That's how we get rid of that percent symbol. So we get 15 hundredths, okay? So then that becomes the problem that I'm going to solve. 15 hundredths and then times 300. So the math works a little bit differently. I'm basically going to take 300 and multiply it by 15. So I get 0, 0, 15, put in a placeholder, 0, 0, 3. And when I add up, I get 0, 0, 5, 4. Okay, so now I'm at 4,500. But remember what we needed to do. We need to go back and we need to count how many digits came after decimal points all together. And what I got was 2 digits. So then I'm going to go to my product and I'm going to place the decimal point so that there's 2 digits after the decimal point. So this answer is 45, which is what we expected. So again, we would have 45 students have cheese as their snack. Okay? So let's try something different other than cheese. It says find the number of students at York Middle School that have chips as a snack. So let's find chips. Chips, oh, here they are. And it says chips is 18%. And then we get to decide which way we want to solve the problem, okay? So personally, I think changing to decimals is as simple as anything else, so that's what I'm going to do. I'm going to divide by 100 and get 18 hundredths, okay? So then I'm going to take that 18 hundredths and I'm going to multiply it by the number of students at that same school, which is 300. So off to the side, I have 300 times 18. So I get 0, 0, 24, placeholder, 0, 0, 3. When I add those together, I get 5,400. But I got to go back and look at my original factors, and I notice here are 2 digits. So my answer is also going to have 2 digits after the decimal point. So my conclusion is 54 students ate chips as a snack. Okay, I'm going to have to take that as and move it because it is messy. Is it not going to let me to? Oh, there we go. Finally. As. There we go. Okay? All right. Now I'm going to go to the next screen and we're just going to talk about what if I have really large percents or very, very small percents? How's that going to change? We're only going to do 3 of the examples. Okay? All right, so let's go to the next page. So we'd already glued down our foldable and our examples and had our paper titled. And so now we're still going to do, it doesn't matter what our numbers look like, process is the same. So I think what I'm going to do is kind of alternate what I'm going to multiply by. And I'm just going to say it this way. I think that when we have a percent greater than 100%, and this is just my opinion, when I have a percent greater than 100%, I like to change the fraction, or change the percent to a fraction, okay? For some reason, that just kind of works out better for me, all right? So that's okay. So for example, if I have 136%, it's going to be 136 hundredths, okay? Now, on the other end, if I have a percent, oops, okay, here I am with trouble spelling again, less than 1%, I like to change the percent to a decimal. Just for some reason I find that it works out better. So if I have something like 0.32%, I'm just going to move the decimal point left twice, and that's going to give me 0.0032 or 32 10,000ths. Okay? Now again, you might not want to do it this way. That's okay. Pick whichever way you want to do it. So we're going to do questions 1, 3, 4, 5. Okay, those are the only, and then we'll leave the other two. I decided I wanted to do one of each kind. So here we go. On number 1, I'm going to take my percent that's over 100, and I'm going to make it a fraction. I'm going to make it 145 hundredths. Of always means to multiply, and we're going to multiply by 320. And because I have to have two fractions, I'm just going to create a denominator of 1. All right, so I'm going to see what I can simplify by. Let's see. 10 can go into it 100 10 times and into 320 32 times. Let's see what else. 2 can go into 10 5 times and into 32 16 times. What else? Ooh, 5 can go into itself once and into 145. Let's see. It goes into 14 twice, which is 10 with 4 left over, and into 45 9 times. So what I'm left with is 29 times 16. So I'm going to do that over here. And I get 54. 12 and 5 is 17. Put in a placeholder. 9, 2. I get 4, 16, 4. So my answer is 464. Okay. Let's try the next one. We've got 275%, so we're going to write it as 275 over 100. Of means to multiply, and we're going to multiply by 4. Now we're going to create a fraction out of that 4 by giving it a denominator of 1. All right, let's see what we can do. That's interesting. Guess what? 4 goes into itself once, and into 100 25 times. Oh, 25 goes into itself once, and goes into 275. Let's see, it goes into 27 once with 2 left over, which is 25, and once again. So I'm left with 11 times 1, which equals 11. That wasn't so bad. All right, let's switch gears, and now we're going to do multiplying a percent that has a decimal times a number. So let's see. I'm going to make this a decimal, so I move the decimal point left twice, and that gives me 0.003 of, remember, is times, and then 200. So off to the side, I'm just going to multiply 200, and I don't need all those extra zeros, so I'm just for the time being going to multiply by 3. So I get 600, but then I need to go back, and I need to count how many digits came after the decimal point altogether, so I have 3 digits, which means my answer will also have 3 digits after the decimal point. And what I end up with is an answer of 0.6 or 6/10. That wasn't so bad. All right, one more decimal one. Let's see, 85%, 0.85, so 85 hundredths of a percent. So we're going to cross that off and do division this way, fill up that blank spot. So that becomes 85 10,000ths of, which means times, 600. So now we're going to do the math, and we're going to multiply 600 and 85. So again, I'm going to temporarily ignore those zeros that come in the front of that decimal. So let's see, we get 0, 0, 30, put in a placeholder, 0, 0, 48. So we get a 0, 0, 0, 11, 5. Now we go back, and we count how many digits came after the decimal point, and I see 4 digits. So my answer will also get 4 digits, and my final answer works out to be 5 1/10. Don't include any extra zeros at the end of your numbers. Okay? All right, have a good time with this, guys. We'll talk to you later.